Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If you know you have not subscribed, please subscribe, share, and let's enjoy together. Today we are done with the canonical forms. Now we are going to look at the solution to the second order PDE. Is that okay? So this is the solution to the second order PDEs. Is that okay? Good. So you are going to look at this first. That's the second order equations of the form uxx equals. So this is the second order equals f at xy, and uxy equals j at xy, and uyy equals f at xy are always simple to solve. So to solve things like this are always simple. So you're going to consider equation in the form like this. You solve them before you move ahead to the next ones. Is that okay? So let's look at how we can solve it. So we have example here. Find the general solution of uxx equals 12xy. How do you solve something like this? Is that okay? So for us to solve this particular question, all you need to do here is, let's see, we have uxx equals 12xy. What it means is that we want to get a solution of u in terms of x and y of a function like this. So for you to be able to get this solution means that we need to able to remove this x and that x from there. And for you to do that, this has already been differentiated 2 times or twice. So you want to take it backwards. And you know that the reverse of differentiation is what? Integration. You are going to reverse this to get back this. So you need to integrate this. Okay. So for you to be able to do this, you need to integrate first. So you're going to integrate this. But remember partially. You see, this is x. So we are integrating with respect to x. So this will give us ux equals. Now if you integrate this with respect to x, we are just considering the x, not the y. So the y is treated as just this 12, which is constant. So the y is constant. So if I integrate x, I'll get x squared over 2. And that 2 will go into the 12 6 times. So we have 6x squared y plus the constant c. But because there's partial differentiation, and you know that here we are talking about x and y, and we are integrating with respect to x, then the constant becomes a function of y. So here will give us f at what? Y. Then we integrate again, still with respect to x, because we have x here. So this gives us u equals, now this one here with respect to x. So if I integrate x squared, I get x cubed over 3. 3 going into 2, 6, 2 times, so I have 2x squared, x cubed y, okay, plus, remember, we are differentiating with respect to x. So let's say that this is treated as constant because of we are integrating with respect to x, integration. Then if this is treated as constant, it's like when I have 2 here and I'm integrating 2, I'll get 2x. So here 2 will be what? X multiplied by what? Y, because it's treated as constant, and plus, let's say, j of y. So we bring another constant, but that constant is also in terms of y. Okay, so this is what we have as our final answer. So therefore, we need it in terms of xy equals 2x cubed y plus x f at y plus j at y. So the final answer to this particular question here is this. Is that okay? Good. Now let's look at the second example. Let's see how we can solve this. Find the general solution of uxyz equals x plus cos x x. X plus cos x. Okay. So if you want to do this, because He said that we are interested in getting this f at x, y, z, means to reverse this back to this, okay? And we said that the reverse form of differentiation is integration. This has been differentiated 3 times. So the first thing that we are going to do is that I'm going to integrate this, right? So I have the integral of u, x, y, z equals the integral of x plus cos x. Now here I'm integrating with respect to z, so you are doing it backwards, okay? So here will be z. So remember, since you are integrating with respect to z, any form of x and y will be treated as constant. So what it means is that if I integrate this, I have u, x, y equals, this is a constant, so when you have a constant and you integrate, this will come and multiply this. So this will give you xz. Is that okay? Plus cos x. So if you look at this cos x, the cos x here is a constant because of the x. Okay, so this z will also multiply this, which will give you z cos x. The z will not multiply the argument, no, it will come down here. So now this is the next one. It means you are going to integrate this one again with respect to y. So I have the integral of u xy equals the integral of xz. Okay, here I forgot the constant. So there must be a constant here. What will be the constant? Remember, here is x, y, z. Now I'm integrating with respect to z. So the constant is b in terms of a function of x and y. So my constant becomes f at x comma y. Is that okay? Because it's x and y is what I'm treating as what constant. So therefore my constant becomes a function of that. Thank you very much. So here I have xz plus z cos x plus this side, okay, f at xy. So this one, remember I'm integrating with respect to y. So with respect to y, here we left with what? U x equals. Now if I'm integrating with respect to y, it means that I'll multiply this one by y. So I'm going to have x, y, z plus, with respect to y, there's no y here, so all treated as constant. So I'm going to have y, z cos x. Then when it comes to this place, yes, there's y in this. We have y here. Is that okay? It means that we need to integrate this, because since there's y here, it's no more a constant. So if you are integrating this, it's very simple to do. All you need to do is that you change the functions there to, like, you see, when I'm differentiating f, a function, I will just write f prime. So if I'm also integrating, what I need to do here is that I will change this function to, let's say, a different, I mean the f here to a different letter, or I will change this f to a capital F. Sometimes even the book will, some place they will make here capital F, then they will change it to small f. That means you have integrated it. So I can decide to change this one to, let's say, capital F. Okay, so that I have plus capital F of what? X, Y. It has been integrated. So what it means is that here is not treated as constant. That's why I have to do something about it. You can decide to maintain it, no problem with that. But you don't need to multiply here by y again. No. Okay. Plus that with it. So you need to get another constant, g. Okay, you need to get constant. Now in this constant, what is it going to contain? The constant is going to contain x and z, right? So you have x, then you have z. So I think that is it. Yeah. Then we move on to the last one, which will be u, integral of u x, right, will be equals to integral of x u z plus y z cos x plus f at x, y plus j at x, z. Okay, then you close the bracket with respect to x finally. So I have u equals, so I'm going to get the final answer. Now remember, I'm integrating with respect to x. There's x here, so I'll treat this x as a variable. If I integrate x, I'll get what? Half x squared, right? Then my y, z comes. Now when I come here, there's x here. If you integrate cos x, you get what? Sine x. If you differentiate cos x, you get negative sine x. But if you integrate cos x, you get positive sine x. Take note of that. So here gives us plus y, z sine x. Okay, good. Then, because we are integrating with respect to x, so all this will be treated as constant. Now if I integrate with respect to x, here I have to integrate this. So I've said you can decide to maintain this, or you change the variable here. Let me maintain it. So f x y, because there's x here, plus this one is going to give us, there's x here, so you can maintain the g or you change it. So I want to maintain it. I have x z plus the other constant. Let's use h. Okay, now for the h, I'm integrating with respect to x, so I'll have what? Y and what? Z. So this becomes the final answer to that question. Thank you very much. Thank you very much. Let's move to the next question. Now let's look at the next example. That's the last example to this. Then we move on to the other solution to the second order PDE. So find the general solution of uyy plus u equals 0. In fact, this does not look like the previous two examples that we solved already. So how do we solve something like this? This is very simple and easy to do it. Do you remember ODE, where we're having something like, say, y prime prime plus y prime plus, let's say, y equals 0. Then we'll be having this. These things were called characteristics equations. Good. Now, when it comes to the ODE, we looked at three things, right? That's what we were taught. One was you check whether it is distinct roots, means that you get roots, two roots, or you check whether it's repeated roots. Is that okay? Not two, like distinct root. Then you check the repeated root, whether it is repeated root, or you check whether it's a complex number. These are the things that we were taught. Is that okay? And we learned it. So if you look at everything, all of them were having their special formulas. If it is distinct root, the formula we use. If it is repeated root, the formula we use. If it is complex root, the formula we use. So let's look at, if you look at this, this looks like this, right? So let's look at how we can relate this to this particular one. If you look at this one, we have u y plus u equals 0. So if you are relating this to this, the uyy will go with the u prime prime, because this is the second order, this is the second order. This is the first order. We don't have any first order. This is the unknown function. We have unknown function. So this u also go with what? The y here. Is that okay? Okay. So if I'm to write this, it means I'm going to have uyy will be what? Lambda squared. The u, in fact, we pick the coefficient of the unknown function. So the coefficient of y is 1. Here to the u, the coefficient is 1. So plus 1 equals to 0. Then we solve this characteristics equation. So if you solve this, we have lambda squared equals negative 1. Is that okay? So in this case, we take square root on both sides. By taking square root, we bring plus or minus there. That gives us lambda equals, what is the square root of negative 1? That gives us the complex number, which is I. So plus or minus what? I. So this is what we have. After getting this, what next? This is a complex number. So as I said, we have three things here: distinct root, repeated root, and a complex number. So all of them have their formulas. This is complex number. So let's look at the formula for the complex number. The formula for the complex number, let me relate it to the ODE again. For the ODE, the formula is given as UX equals E to the power alpha X. Is that okay? Bracket open. C1 I think cos beta X plus C2 sine beta X. So this is a formula when it comes to the OD. So this one belongs to the complex numbers. So C1 cos beta X plus C2 sine beta X, e to the power alpha X is multiplying all this. Somebody may ask, where from this alpha, where from this beta? In fact, you know, when it comes to the complex numbers, for this we have the real part and the complex part. So we can solve it sometimes. You can solve a question and you get something like, let's say alpha equals 2 plus or minus 3i, something like this. Okay, so when it's happening like this, this one becomes the real part, and this becomes the complex part. Okay, so that's what we are talking about. So in this case, we can have the alpha. Our alpha is treated as the real part, plus or minus beta I is also treated as what? The complex part. What it means is that the alpha we are seeing here is the real part, and the beta we are seeing here is the complex part. Is that okay? So if you want to do this, let's then relate this one to PDE. If I'm relating this to PDE, what it means is that for PDE we are dealing with u, okay, in terms of x and y. This will be u e to the alpha x. Remember, we are integrating with respect to y. So in this case, here is no more x but what? Y. Is that okay? Bracket open. Now, due to the PD, the nature of it, and it is partially, if you integrate with respect to y, okay, the constant, which is C1 and C2 in OD, becomes the constant or the function of what? X in this case. So here will be f at what? X cos beta y plus f at some books can say, let's say j at x to differentiate it, sine beta y. Is that okay? So this becomes the formula you are going to use. Now, look, here you can see only the complex part. You cannot see the real part. What it means is that the real part is 0. So it's like 0 plus or minus I. So the 0 there is the alpha. So what I'm going to have here is that e to the power alpha. Now the alpha is 0. So e to the power 0 y equals to bracket open f at x. Is that okay? Cos. Now b will be what? B will be 1. Is that okay? Because that, if like we have 3i, then our b will be 3. Is that okay? Now this is just I, so the coefficient of the I is 1. So b is 1. So 1 times y is y. So this gives us cos y plus j at y. So here, sorry, j at x. And this gives us what? Sine y. Is that okay? So this is what we have. There is no bracket here, it's rather multiplying. I mean, there's no equals to there. So our final answer, if this is 0, 0 times y is 0, e to the power 0 is 1. So what it means is that our final answer here becomes f at x cos y plus j at x sine y. So what I'm trying to say here is that understand these things and make sure that you're able to relate yourself to the ODE very well, because some of the questions need an idea from what ODE. Thank you very much for watching. You will then look at the main integration for the second order, where you'll be applying the canonical forms and you'll be able to integrate. Please follow for more. Some of you download and go and share. Please share the link to them so that they also watch and I get something out of it, because I'm spending a lot to do their videos. So try to watch, share for me, but don't download and go and share the real video then. Thank you.